All right, let's take a look at determining the distance from a velocity versus time graph or speed versus time graph. Velocity, speed, remember the same thing. But when we look at a velocity versus time graph, again, we can figure out velocities at different times. So like we could tell at 4 seconds that this was moving at 1 meter per second. But at 8 seconds, it was also moving at 1 meter per second, the same as 10 seconds, all that kind of stuff. But if we wanted to figure out the distance, how far something went on a velocity versus time graph, we could do that by finding the area. So the area is something that we uh, learned before in math class, but area is the same as length times width when you're talking about rectangles. It's this 1/2 base times height when you're talking about triangles. So if we wanted to find the area for this section, it has to be underneath the graph. So like the graph part would be right here. And we would take the length, it stretches across 10 seconds, times the width, and it goes up to 1 meter per second, and we multiply them together. We get 10 meters. We could do that on other graphs too, and I'll show you how that's done. So when we take a look at a velocity versus time graph, to figure out the distance traveled during this or throughout this graph, we have to start by separating it into sections because it's not just one shape. We need to kind of separate it into more simple shapes of just rectangles or triangles. And so we can take this part and we can separate it right down here so that we end up having two rectangles, one right here and the other one right over here. And we have to find the distance by finding the area of those triangles or of those rectangles. So each area, because they're rectangles, is length times width. So we take the length for section A. It's 0 to 1, so the length is 1. Times the width, and the width goes from 0 to 15, so it's 15. We multiply those together, and we get 15. The units are meters because our units are really just the units of the length multiplied by the units of the width. It's meters per second multiplied by seconds. Seconds cross out, you get the meters. Okay. For section B, we have to find the area and we take its length, but the length is not 3 because it starts at 1 and it goes to 3. The length is actually 2. The width is how high it goes up, and this one only goes up till it gets to the 5. So width is 5. You multiply them together, and we get 10 meters. So each section goes a different distance, but the total distance is really the sum of them or adding them together. So if we add 15 and 10, we get 25 meters for the total distance traveled throughout that graph. We can take a look at another graph where it might be a little bit more complex, where you can't just split it into two different parts. You probably want to split it into 3. So if we wanted to figure out the total distance here, we might split it up right here and have a rectangle, and split it up here, have another rectangle, and have a triangle. Again, to find our distance, because we have a velocity versus time graph, it's not positions, we have to find area. So each area is length times width. So for the first section, the length would go from 0 to 10, it's 10. Times the width goes from 0 to 4, it's 4. Multiply those together, and it's 40 meters for this first section. The second section goes from 10 to 25. The length is 15, not 25. It goes from 10 to 25, so it's 15. Times the width, it goes up to 4. So we get 60 meters, that one. For this triangle, though, we have to do something a little different because area for a triangle is 1/2 times the base times the height. So I have to use 1/2 times the base. This one also, it's not 25. It starts at 10 and it goes to 25. So it's still 15, like the one above, or this rectangle, times the height. The height also, it is not 10 because it doesn't start until it was at 4. So it goes from 4 to 10. Our height is 6. If I multiply that together, we get 45 meters. So we have the distance and area for each one of those sections. Now I just add them together to get the total distance. And it's 145 meters. And that's how you find the distance on a velocity versus time graph, by finding the area underneath the graph section.